So we're doing some calculations here. So the question is, how much KCl, potassium chloride, can be dissolved in 200 grams of 75 degrees Celsius water? So a couple things that we know here. We have potassium chloride, we have 75 grams of water. And so what you want to do is then you want to go to your chart here. So we have potassium chloride at 75 degrees. And so potassium chloride, KCl, is this guy right here. We're at 75 degrees. That's right here. We want to go up to the top, and we meet this point right here. What solubility corresponds to this? And so we take our guy over here, and we do this. We see it's right at about 50. And so what this means is that we could dissolve potentially 50 grams of KCl in 100 grams of water at the temperature the problem gives us. So we need to remember that 50 grams of KCl in 100 grams of water. And the reason why we need to know that is we're now going to go back to that previous guy here. So we said we could fit in 50 in 100 grams of water. And it's not ignoring me right here. And so what I would do is I want to set up basically a proportion. I'm going to say I've got 50 grams of KCl. Wow, that doesn't look right at all. 50 grams of KCl in 100 grams of water, H2O. So I'm going to set a proportion, and what I'm going to do is I say how much KCl can be dissolved in 200 grams of water. Is that I'm going to say I don't know how many grams KCl, I know I have 200 grams of water. At this point, all we really want to do is to solve for x. We're going to cross multiply the 200 up here, multiply the 100 up here. And so when we do that, we grab our calculators here. You get 200 times 50. And so 200 times 50 up here. And so we get 10,000. And so I get 10,000 over here equals 100x. Divide both sides by 100. And so in this case right here, I say 10,000 divided by 100, I get 100. And so x equals 100. And so I could manage to fit 100 grams of KCl into 200 grams of water at 75 degrees C. Now, to some extent, that should make sense here because we said that from our chart that we could fit 50 grams and 100 grams of water. And so in 200 grams, I should be able to fit twice as much. And sure enough, I can. But this is basically the strategy you want to work here, is that you're going to set up a proportion using on one side the values you get off of your solubility chart. And then you use that, set up the proportion to find what you're looking for. So this is what we have for this one. So the next question, what is the smallest amount of 40 degrees Celsius water needed to dissolve 405 grams of lithium chloride? And so the first step we want to do is that we know we have water, it's at 40 degrees C, and we know we have lithium chloride. So let's look at what happens at 40 degrees C for lithium chloride. And so we want to go back to our temperature solubility graph here. And so 40 degrees C and lithium chloride. And so lithium chloride is right here. We're at 40 degrees Celsius, so we follow this guy up until we reach here. We're then going to go over, and we find that that's right at 90. And so I know I can fit 90 grams of lithium chloride in 100 grams of water. So 90 grams lithium chloride in 100 grams of water. So I say 90 grams lithium chloride in 100 grams of water. And I'm going to set this equal to what I have here. It says I want to dissolve 405 grams lithium chloride. So that's the amount of solute up here, so 405 grams lithium chloride. And I want to find how much water. Well, this is per 100 grams of water here, so I'm going to put this over x. And so once again, I'm going to do my nice little cross multiplication gig here. Multiply the x up top, multiply the 100 up here. And so in doing so, I end up getting 90x over on the left is equal to 100 times 405, which is 40,500. If I'm doing the math in my head right. Divide both sides by 90. So both sides by 90 here. So 40,500 divided by 90. And so in this case, I get 450. And so my x is 450. So I would need 450 grams of water to do this. Significant figure-wise, basically in this case, is that what you want to do is that the number that you there are two numbers that are important here. The first one is the one that you sort of measured off of, that you were given the problem, which has 3 significant figures in this case. The other one that's important here is the one you got off your graph. When we did the graph, how far did you measure it? Because really this is a case where whenever you read your graph, is that reading it determined the number of significant figures. Did you round to the nearest 10? Was this like, say, 94 and we rounded it down to 90? If it is, we only use one significant figure. Most of the time, whenever you're using the graph that at least I give you here, is that you should be able to get to the nearest gram. It may be estimated. You may not say, well, this is either 91 or 93, 92, but you still want to go to the nearest gram. And so in this case right here, even though 90 only has one significant figure, we measured this to the nearest gram here, and so that would have 2, because that's just simply how we measured it. And so our answer then should have 2 significant figures, which fortunately here it does already. And so our final answer here is that I need 450 grams of water in order to dissolve 405 grams of lithium chloride at 40 degrees Celsius. So that's how you sort of set that up right there. Let's do a couple more on this case. And so to do that, we'll go forward a couple spots. So 200 grams of saturated ammonium chloride solution at 85 degrees Celsius is cooled by 50 degrees. What mass of ammonium chloride is precipitated? Precipitated because, remember that at 85 degrees, we can hold more ammonium chloride than we can at 50 degrees. And so some of it's going to fall out unless it goes super saturated, but presumably it won't. Most things don't. And if it does, you have to do it very slowly and do it very carefully. So we need to find how much ammonium chloride is in the solution at 85 and how much it could hold at 50 in order to find the difference. And so we're looking at 85, we're looking at 50 for ammonium chloride. And so let's take a look, 85 degrees and 50 degrees for ammonium chloride. And so we're interested in what happens at, we said, at 85 degrees and at 50 degrees. And we're talking about ammonium chloride, that's this guy right here. And so we follow this guy up to right there. That's our first one here. And following this over, we have 70. So at 85 degrees, we can fit 70 grams in 100. And at 50 degrees, we're going to follow this one up to the ammonium chloride one right here. Going over here, we have 50. So 50-50 right there. And so here's what we know. At 85 degrees, we can dissolve 70 grams of ammonium chloride. At 50 degrees, we can dissolve 50 grams of ammonium chloride. So 70 and 50 are our two guys right here. So taking a look here. Oops. So let's start off with what we've got here. Is that we know that at 85 degrees, we can fit 70 grams in 100 grams of water. Okay? We know at 50 degrees, we can fit 50 grams in 100 grams of water. And we're going to set up two equations for these guys. For the first one here, we have 70 grams, and we're told that we have 200 grams of saturated ammonium chloride solution. Okay, now in this case right here, we have 200 grams of the solution, not 200 grams of the solvent. So for this one right here is that we don't know the amount of ammonium chlorides in here. That's X. But we also don't know the amount of solution. We know that we have 200 grams of the whole solution. So we'd say 200 minus X is what we have here. And the same thing is true over here. Is that, actually we're going to call it Y in this case, because for the other one we don't know. It's going to be 200 minus Y. Figure out how much it'll hold here. And so in this case right here, let's go ahead and see what we can do to solve this here. And so on our first one, our 85 degrees, we're going to cross multiply, same as what we did before. And I'm going to write this at the top just so we have enough space here. And so what we have here is we have 70 times 200 minus X equals 100X. And so doing this, we have 70 times 200, which should be 14,000, I believe. Once again, if I'm doing my math right, 14,000 minus 70x equals 100x. And so we'll add 70 to both sides, 70x to both sides. And in doing that, I end up with 14,000 equals 170x equals 70x. Divide both sides by 70. And so if I take 14,000, sorry, not 70x, 170x, my bad. So 14,000 divided by 170. And so we put that in your calculator, 14,000 divided by 170. I find that I have 82.35. And so this is the amount that I start with here, is that originally I could dissolve 82.35 grams of ammonium chloride in the solution. In the second case right here is I'm going to do the same type thing I did before. I'm going to cross multiply these two guys right here. And so I'll do this one at the bottom. I know there's another problem that's down here, but we're going to sort of ignore that other problem. We'll delete it. We'll go back to it in a second. So what I have here is that I have 50 times 200 minus y equals 100y. Distribute this through. 50 times 200 would be basically 10,000 minus 50y, that's a 5, equals 100y. Add 50y to both sides. And so I, in this case, get 10,000 is equal to 150y. Divide both sides by 150. And so 10,000, put in your calculator, 10,000 divided by 50, and I get y equals 200. Okay? And so I've got a little bit of a problem here, so let me take a look for just a second. I see. I apparently can't do math here. Is that 10,000 divided by 150 is very clearly not 200. So we're going to get rid of that guy right there. Is that instead it's 66.66, and so we get 66.66. And so grams here. So we started off with 82.35 grams. We ended up with 66.66 grams. And so the difference here is how much of this cannot be held by the solution anymore. It's how much precipitates out. And so we take our 82.35 and we're going to subtract from that our 66.66. And we get for our final answer 15.69 grams. Now, significant figures is we started with just one up here. And so the ones that really, since everything that we're involved here based around the 100 spot, we're going to end up with just one significant figure. So our final answer here is actually just 20 grams. So there would be 20 grams of ammonium chloride that we precipitated here. So this is how we go ahead setting that one up and doing that one. And I'll tell you this, that's about as complex as they get. That's about as complex as they get. A different type of one, though, that also does have some complexity to it is to actually figure out what the concentration of one of these solutions is. And that's what we're going to have on our next problem down here. So in this case, it says, what is the percent by mass of 40 degrees Celsius saturated sodium chloride solution? So we know we're at 40 degrees Celsius, and we have sodium chloride. So that being said, we want to go to our temperature solubility graph. Ooh, not what I meant to do. So temperature solubility graph right here. Oops. And so we said 40 degrees Celsius sodium chloride solution. And so we have sodium chloride at 40 degrees. So sodium chloride is NaCl right here. 40 degrees is right here. So that's our blue line. Going up to our blue line right here, you could sort of go across here, and you see we're right about, it's a little lower than that. My line's not very good. That looks to be about maybe 30. Keeping in mind that my green line's a little high because the smartboard's a little off on where my mark is here. That looks to me to be somewhere in the neighborhood of probably about 37, 38. I'd say probably 38 is what I get here. So I have 38 grams per 100 grams of water is what I've got here. And so 38 per 100 is what I've got here to start with. And so let's take a look back at what we have here. And it's not listening to me again. Okay, so I know that I've got 38 grams of NaCl per 100 grams of water. And I know that because I am saturated, and I know I'm at 40 degrees. So I've got those things here. Question is, what is percent by mass? Percent by mass, if you remember the calculation for this, is basically the number of grams of solute over grams of solution. So, to do this, we want to find the percent. Do we know the number of grams of solute? If we have 40 degree saturated solution, yes we do. It's 38. 38 grams. What about grams of solution? Well, we have 100 grams of water over here. That's our solvent. To find solution, we have to add those up. And so to find the solution, we do 100 plus 38. 138 grams. And so to find our percent by mass, and we got also, we forgot about this, I have to multiply by 100 in both cases to get it into percent. So to do this, we'd take 38, divide it by 138, and we get 0.275 times 100, and that gives us 27.53%. Significant figure-wise, the only thing we really measured was over here originally, is that when we went to the chart, we got this was 38. And so since that's 38, that would be basically to the nearest degree, 2 significant figures. So we'll round our final answer to 2 significant figures. So what we have here is a 28% solution. So if I have sodium chloride at 40 degrees Celsius, it's saturated, it'll make a 28% salt solution.